Welcome back. We are ready to begin Module 8, Project Scheduling, in the Using Open Workbench with Clarity self-paced training course. In this module we have 4 learning objectives. The first one looks at the factors and considerations affecting the use of AUTOSCHEDULE, and as you may know from the previous modules, AUTOSCHEDULE is the method in Clarity and Open Workbench that is used to do project scheduling. The second lesson deals with one of those factors, and one of the major factors in fact, that's the critical path. And so we'll touch on that a bit. It's possible to spend hours on critical path, but we're just going to get the top of it enough to be able to do the scheduling that we need to do for this course. The third lesson deals with using AUTOSCHEDULE. We'll look at some of the rules and how AUTOSCHEDULE works, and then we'll spend some good amount of time doing demos on it and looking at it from different ends, unchecking different variables and seeing how AUTOSCHEDULE responds, with the objective that you become familiar with AUTOSCHEDULE and can easily incorporate it into your project scheduling method. And then in the fourth lesson we'll look at using fixed and variable task durations, especially around fixed durations. We've talked about this in a couple of modules now, but I want to give some special weight to that because it too often is not well understood. So we will talk about fixed duration scheduling. And then finally, at the end of the module, we will have a hands-on exercise. Now, getting into the first lesson, we'll talk about scheduling considerations. And the first one is on task dependencies. Of course, scheduling in any scheduler application, whether it's Microsoft Project or whether it's Open Workbench, all depend on and are based on task dependencies. In the last module, Module 7, we dealt with dependencies, and we talked about dependency networks. So that's what this is. The scheduling, project scheduling is based on having a dependency networks created through task dependencies. The second item is critical path, the critical path, and we're going to talk about this further in the next lesson where we explain what this is about. But very simply, the critical path is the longest path. So when we look at that dependency network that we saw in the last module, the critical path would be the path that you can follow from the beginning to the end that is actually the longest duration chain. The next item is calculating task durations, and we'll be talking about that some more in one of the later topics, especially the one around fixed durations. But when we look at AUTOSCHEDULE, we'll look at how AUTOSCHEDULE affects task durations and how we affect AUTOSCHEDULing based on task durations and what we want to accomplish with AUTOSCHEDULE. Do we want task durations to be set by us, or do we want Clarity Open Workbench to set the task duration for us? The next item is resource constraints, and we'll see when we do AUTOSCHEDULing we can have a choice of whether we do resource constraints or not. And by that what I mean is basically resource leveling. And so by checking resource constraints we do an AUTOSCHEDULing, and we then, by having that checked, it ensures that resources are not overcommitted or overcommitted to their allocation to the project. And then the next one is on task constraints, and when we talked about this, when we looked at task properties, and we saw that there's task constraints that can be defined in the advanced task properties tab, we talked about not really getting into that in this course, not recommending it because we're using the dependency network to set our schedule. So we're not really talking about task constraints, so we just won't use them in this course. And then finally, using AUTOSCHEDULE, and of course we want to get very comfortable with AUTOSCHEDULE because it is the heart of the scheduling system in Open Workbench, and once we understand it, it is easy to do and it helps us a whole lot. Now the second lesson was on the critical path. So we have several slides to talk about it from a concept standpoint. And simply, the critical path is the longest path through the project. We said that before. And one test of this is that any delay in a task that's on the critical path will delay the project. So if any one of the tasks has a 1-day delay in it, and this chain begins at the start of the project and it goes from task to task to task, all connected with dependencies. So there could be a chain of 20 tasks that take you from the start of the project to the end of the project. And the critical path is the one that is the longest. And so if we add 1 day to any task along that path, it would delay the project by that 1 day. Conversely, and this is used a lot in industry, and that is if we take a day off of one of those tasks, we shorten the project by 1 day. So when we talk about things in the industry about crashing the schedule, that's what they do. They go look at the critical path and they look for ways to reduce individual task durations so that one task duration reduction equals into a project duration reduction. And then part of the process with critical paths and the longest path is that the ones that are not critical have float in them. And the system will tell us that. It calculates all this for us. So how much float does a certain path have? It could be that it has 1 day float, which means we could increase one of the tasks in that path by 1 day and not affect the end date of the schedule. Could have 5 days of float, which means any one or all of them, if we add 5 days total to a path, we would not affect the end date. So float is another important consideration in critical path process. So knowing the critical path and knowing the float, and Open Workbench calculates these for us and displays the numbers if we want to choose to look at them. And one of the things we saw in an earlier module was when we dealt with highlights, we saw that the critical path is identified in red in Open Workbench. So that makes it real easy to follow the critical path. And then next on here, the point shows that the PM then knows where to put their focus in trying to ensure that there's no slippage. Of course, you would want to do that on the critical path so that you do not then delay the schedule. So that's where the project manager should be giving some emphasis and should know what is critical path. And these techniques with critical path, also called critical path method or CPM, this is not peculiar to Clarity or to Open Workbench. This is industry standard. I mean, it's all also in, for example, Microsoft Project, but it's all beyond all that. This is total industry. That CPM is something, it even preceded the use of desktop applications, scheduling applications. So the concept that were built or actually in the 50s with CPM actually then were incorporated into virtually every desktop scheduling application, including Open Workbench. Now let's just take a real quick and simple look at calculating critical path. And here we have a very simple dependency network just to explain the concept very easily. And so when we look at this simple one here, the question is how many paths are there through this network? And the answer, of course, is, well, there's two. One path goes from A, C to D, and the other path goes from A to B to C. And of course, in real life, the dependency network is much more complex than this, but the concept is the same. And so you can figure out the paths, and actually Open Workbench does that. And then the next thing is calculating critical path. Well, which is the longest? So now what we've done is we've taken that simple diagrams and we put some days duration for each task. And so if we now look at those two paths, well, what is the duration of each of those two paths? So the ACD path has a duration of 2 plus 6 is 8, plus 4 is 12. And the other path, A to B to D, has 2 plus 8 is 10 and 4 is 14. So the bottom path is the critical path. because it's the longest. It's 14 days long. The upper one through C is not the critical path. It's only 12 days long. And in fact, because of that, it has 2 days afloat, which means that you could take 2 days longer on C, path C, and not affect the end date of the project. So that's the basic simple look at critical path methods, critical path calculations. It is actually much more complex than that, and fortunately, Clarity does it for us.